So today we are going to do software engineering. Right. So we did up to agile programming, and today we want to finish it. Okay. Not finish it. We want to do at least 3 or 4 topics. Okay. Right. So far we have discussed 3 topics. Those are introduction, software process, and agile software development. So today we are going to finish 4, 5, 6, and 7. Okay, 4, 5, 6, and 7, because I have done those topics for batch 1. So that we can combine your 1 and batch 1 together and finish it. Okay, so that is the idea. Right. Requirement engineering. Right. So we are going to discuss following topics under requirement engineering. Functional and non-functional requirements, requirement engineering process, requirement elicitation, requirement specification, requirement validation, and requirement change. Okay, right. Okay, so this topic is extremely important if you are interested in career software development field. Okay, so let's look at now. Remember, we discussed that when it comes to developing software, we have few challenges, complex tasks, and also the business challenge or the business demand. Highly competitive environment businesses are running. So these best business challenges are there. And also it's a project. So therefore we have commitments. Okay. So those are the main concerns, complex and also business challenges. So how to tackle that? The project management, software engineering. Okay. So we manage it. At the same time, we use the engineering approach because it's a complex task. Okay. And then we discussed that there are different ways we can develop software. The waterfall approach and the iterative approach. And last time we discussed another variation of iteration. It's again iterative, but more focused on working on rigorous, competitive, dynamic business environment. So that is agile. Right? Linear approach, iterative approach, and agile approach. It's an evolution. Okay. Right. So then we start discussing the software development activities. Actually, today we are going to start studying the software development activities in detail. So whether it is waterfall or iterative or agile, we have to do certain tasks in software development. Okay. So only difference is here we used to do those tasks one after other. We finish one and do next. But here, these tasks are done in iterations. Here also these tasks are done in iteration, in a very small iteration, in a very dynamic overlapping manner. Right? What are those tasks? Right? What are those tasks? So you have the problem definition. Right? You have the problem definition. And also you can call it, so this involves understanding the problem, feasibility study. Right? So define the problem and feasibility study. So you don't have that as a specific topic here. Okay. What we are going to start is requirement analysis. Right? Requirement analysis. So once requirement analysis is done, even while you are doing this, agile development, we have to do the design in the solution, development, testing. And that is also not the end of the story. We have another task, that is evolution and maintenance. Those are the topics that we are going to discuss. So requirement analysis first we are going to look at, then we are going to look at design, then development, testing, evolution and maintenance. So now if you look at the syllabus, rest of the stuff, right? So you have the, I will go to the big picture. So first we are going to discuss requirement engineering, that is requirement analysis. So these three topics are sort of overlapping of design and development, right? Development. So this is your testing part and evolution part. Okay. So there's another task in software engineering, that is actually sometimes this is confusing. So some books refer to this as development. So design, development. Then they include another one after testing as implementation. So there, when they some people refer to implementation as deployment. Deployment. So then for them, design, development, testing, and deployment. Those design, development, testing, and implementation. But some others use the word implementation for development. Okay. So here what they have used is here they use the word implementation as for the development. Okay. So they have not taken the deployment again. Remember, they did take the problem definition and feasibility also, because this is a software engineering subject. So they have not taken deployment also as a specific option, task. So therefore, we have been discussing the requirement analysis, the designing, development, we call it implementation, and then testing and evolution. And we are not going to discuss the deployment related things. Okay. Right. So that is a big idea. Okay. Right. So let's start discussing the requirement analysis. Right. Requirement analysis. And you might be wondering, what is this modeling then? System modeling. So modeling is done in both analysis and design. Right. So that is something we do in both analysis and design. So modeling. It's not only modeling, but modeling is a very important aspect in both analysis and design. So therefore, they have taken that also, but they are more interested in modeling as a designing concept. Okay, so your syllabus is a little bit confusing so therefore I just wanted to make it clarify upfront. Okay. Right. So now let's move on to the requirement analysis. Requirement analysis. So we are going to look at, I will draw the mind map. Okay. Requirement analysis. So first we are going to look at why do we need requirement analysis? Then we are going to look at what are the types of requirements. So then we are going to look at the challenges in requirement analysis. Challenges. So once you understand the challenges, we are going to discuss what are the tasks in requirement analysis. Okay, what are the tasks in requirement analysis? So why? What are the types of requirements? What are the challenges that we face, and what are the tasks facing those challenges? How to do proper requirement analysis? What are the tasks involved? Okay, so that is our objective. If you know answers for these questions, you are done. You are done. Okay, right. So let's start with why. Why do we have a task or requirement analysis? So the obvious answer is, first I will explain the subject, right? Then I will just rush through your slides. That is the idea. Okay. For each topic, I explain the topic and then I rush through the slides. Okay. Right. So why do we need requirement analysis? It's very obvious answer. So we need requirement analysis because before designing and developing a system, we want to understand the requirement. At least we want to get to know the requirement, right? So we want to first get to know. So next we have to understand. So then we have to understand, because just because someone tell you the requirements, it doesn't mean that you properly understand it. So you have to understand it. So then it's better to some sort of a documentation, because it's a team effort. It's a understanding between two parties, the development team and the customer. So there can be otherwise some misunderstanding, misrepresentations, right? So you better document. And also we want to verify our requirement understanding. Okay, so that is why we want to do requirement analysis. So get to know it, understand it, and document it. And also let's verify it. Okay, sorry, I got disconnected. Right. So that is why we want to do the requirement analysis. Now let's look at the types of requirements. Right? Types of requirements. So you can subdivide requirements into different categories so that we can properly understand it. Or otherwise, sometimes we will miss certain aspects. Okay, we will miss certain aspects. So there are different ways you can define it. One way of looking at requirement is the user requirements and system requirement. Right? User requirements and system requirements. Right? So I'm just clarifying things. I'm just organizing things so that you can learn it, understand it with a lot of ease. Okay. So the user requirements means the requirements that your user is talking, the user is expecting. Right? So he will say, I need this functionality, this system need this, that functionality. And currently we have this kind of a business process. That system must support this, etc., etc. So we call them user requirements. So the user or set of users or whatever, they will say that, okay, we need to handle orders. So we should be able to add a new order, right? Then we have to, then the customer will do the payments. We need the payment handling. So there are some situations where the orders are cancelled, right? Sometimes they return the products. So we have to update the inventory. So those are the user requirements. So we, in agile development, we call them user stories. In rational unified process, we call them use cases. So those are user requirements. So then we have system requirements. It's pretty much the same thing. We look at it in two different ways. So when we say we are developing a system, say order processing system, accounting system, as people having some knowledge on those domain areas, we also know that there are certain things we have to do. If it is a accounting system, we know that there's a concept called double entry. Whenever there's a transaction, business transaction, two entries has to happen. One side debit, other side credit. So those are system requirements. If you are developing accounting system, that kind of requirements has to be fulfilled. And we know that if it is a system, we need to make sure that only authenticated, authorized people can access. All those transactions must be audited or logged. for security reasons. Those are called system requirements, right? So the requirements initiated from the users or the user stories or use cases, and the requirements that we know that if it is a system, we need those. So that is why the software development projects have the help of business analysts, so that they will give you some insight into system requirements. And our software engineers also know certain system requirements with their experience. And of course, that is why you are learning these subjects. You will also get to know that there's a type of requirements called system requirements. Okay, so there is one subdivision. There's another subdivision. I hope this is clear now. There's another way we can classify. That is functional requirements, non-functional requirements. And some people add third type as well. It's sort of a variation of functional requirement called domain requirement. Okay. Either we can just say functional requirements and non-functional requirements, or we can just say functional requirements, non-functional requirements, and domain requirements. So this is different classification. Okay. So therefore there is overlapping all the same things. We are putting it to different views. So functional requirements means the functionalities. Right? So functional requirements means the expected functionalities. Right? We should be able to create order, cancel order, make payments, dispatch. Right? So those are the functionalities we expect. Whenever the goods are dispatched, we have to update the inventory. We need these kind of reports, daily reports, monthly reports. Those are called functional requirements. They are pretty much the user requirements and some of the system requirements. Right? So then sometimes we can identify special type of functional requirements, or sometimes we separate it into a separate category. We call it domain requirements. So domain requirements means different domains. Domain means sub area, right? Or area. For example, when you buy, say, abc.com, you have one domain in the World Wide Web. සිංහලෙකට කියන්නේ වසම කියලා නේද? දැන් ග්‍රාම සේවකට කියනවා වසම. That is his domain. සත්තුන්ටත් තියෙන වසමක්. බල්ලු එහෙම આવොත් එහෙම මරාගන්නේ අනිත් බල්ලෙක් ආව. So domain. So different functional areas have some specific requirements. Some of those requirements are theoretical. Some of those requirements are sort of a regulatory. Sometimes even the government regulations or some standards. Right? Some theoretical aspects, standards, right? Or maybe legal aspects. So those are called domain requirements. Okay. For example, if it is accounting system, every transaction must have a double entry. So that is a domain requirement. It's a theory. Okay. So there can be some standards. For example, if you are doing airline reservation system or airline management system or airport management system, when a flight leaves from, say, Katunayaka, it is supposed to land in different airports all over the world, right? Dubai, London, etc. Now, when an airline leave from here, we have to send the baggage details, the passenger details, because last minutes also there are some check-ins. So we have to send them before the airplane arrive, say Male. We have to send the details to Male so that they can do those right? Processing of the passengers and their baggages. So when there, we can't just send the way we want it. There are some international standards to communicate. So we have to send those messages in a standard format, because otherwise their systems cannot read those things and automate those things. So that is again domain requirements. So we have to follow those standards. Okay. And there can be some even legal requirements. So whenever there's a transaction happens in a bank, so they have to report it to the government or the central bank, certain transactions. So those are some statutory or legal requirements. So these are also functionalities, but special things coming from domain standards, etc. And we call them the domain requirements. Okay. So either we can combine both together as functional, or you can just separate. Right. And especially the business analysts are aware of these domain requirements, because not everyone knows it, right? So unless you have work in airport environment, you don't know that there's a special regulations, there are special formats these people use. Okay, so but that is why you get the help from business analyst in that kind of a situation. Okay, right. So then we have the non-functional requirements. So the non-functional requirements are the non-functionalities. They are not really functionalities in the general sense, but still we need those to fulfill if you want to use it properly. So what are the typical areas for the non-functional? So there are typical non-functional requirements, and very special non-functional requirements will be there as well, right? So these are the typical set. The security, right? So we expect the authentication, authorization, confidentiality. Right? So customer will expect that all the communication will be encrypted. It is not really a requirement or functionality, right? It's a requirement, but it's not a functionality, but it's also a requirement. So we call it non-functional, performance related. So they may need that transaction to be completed within 1 second, say 20 seconds. So there can be some maintainability related requirements. Interoperability, right? So we must be able to communicate with these systems. Okay, so those are called then usability, how user friendly your system is. So that kind of requirements are called non-functional requirements. Okay, so now we subdivided it to another category: functional, domain, and non-functional. Okay. So if you want to do successful software development, you must know these things. Then your mind is very clear, right? Otherwise, people miss those things. So when we can see that when the students start doing their final year project, so they have no idea, right? So they're just doing something for the sake of doing. So what about then if you go for the software field, right? You are going to mess everything. Right? You don't understand the big picture. You just think that it's just some coding. No, it's more than coding, right? It's with a lot of purpose, right? So what are the challenges we have when it comes to requirement analysis tasks? Of course, the first challenge is these requirements can be complex. Of course, if the requirements are not complex, why do we need software engineers to do this? Why do we have a subject called topic called requirement engineering? So engineering is when there are complexities. So requirements can be complex. Understanding the requirements can be also complex, because when the requirements are complex, it's a complex process. Understanding. Okay. So another challenge is when it comes to requirements, there can be ambiguities. Right. So the customers or your client explain it in ambiguous manner. So they are not very specific. It's going here and there. That is a real issue, because not everyone is good in communication. Maybe they also have vague idea about the requirements. So many things. Maybe they have idea, but they don't know how to explain it. Maybe they also have a very sort of a blur idea about what they want. Ambiguities. So that is another challenge. Another challenge is conflicting requirements. Conflicting. So one person says X, the other person says not X, not really X, something different. So then which one we are going to develop? Is it X interpretation of the X or interpretation of the Y? It's related to ambiguity as well, but sometimes it can be conflicting, because one manager's expectation and the other manager's expectation can be conflicting. Okay, so conflicting requirements, ambiguous requirements, complex requirements. So the next one is, can someone tell me at least one more challenge we are facing when it comes to requirement analysis? Just one, just give me 1 minute also. You can think of it. You have to give, I gave you 3 challenges: complex, ambiguous, conflicting. So I just need one more challenge. If you have start studying for the exams, now you must know this challenge. Okay, just give me 1 minute. You can think of it and put it into the chat. Okay, so no one. That means you have not started studying yet, when the exam is only 1 month away. Right. So the next challenge is the change in requirements. So last week the customer is talking one thing. This week he has changed his mind. It's not sometimes not something wrong with the customer. It's not because of the ambiguity. It's not conflicting because the requirements are changing. We are now living in a very competitive, right, dynamic world. The private sector, the business world, they are in a constant competition. So you can't, your expectation today is different from the expectation last week. So you have found a better way of doing that. So that is why the requirements are changing. That is why we have to keep changing our software. That is why we have evolution phase. So while we are gathering requirements and designing and developing, also these requirements may change. So when we gather, it is X. When you are developing, it is not X now. It's X1, now X10, version 10. So those are some challenges. Change in requirement, conflicting requirements, ambiguous requirements, complex requirements, right? So we must know how to tackle those. And now let's see how we can tackle those. That is how the requirement engineering is done. How does engineers do those tasks, facing these challenges, and ultimately achieve these objectives. Okay, achieve these objectives of getting to know, understand, document, and verify. Right, what are the tasks? The task number 1 is, obviously we must get to know. Right, so that is, we call them gather requirements. Gather. Okay, so once we gather, remember we have to understand. Right? We have to understand. Just because we know the requirement doesn't mean that we have understood. So we have to analyze requirements. Now we have gathered, we know, and we have analyzed it. Now we want to do some documentation as well, some verification as well. So therefore we model. Okay. Remember you have a topic called system modeling. Now you know why it is there. So then we have to model. Actually, the documentation will happen as part of the modeling as well. But anyway, let's put it, you have to document. And we have to verify our understanding, our documented requirement, verify or validate. And that is how requirement engineering process work, or requirement analysis or requirement task happens. Gather, analyze, model, document, verify or validate. So let's take one by one task and how to do it. Then our subtopic is over. Then we can move to the design. Okay. Right. Gather requirements. So how do we gather requirements? So this is the mind map. So this is the what you are expected to know as part of your studying. Studying is not taking a note and memorizing like a parrot, right? Useless thing. But if you know the big picture, if you know the context, if you know how they are related, that is you have studied. අධ්‍යයනය කරනවා නේද? පාඩම් කරනවා කියන්නේ මහා හරක් වැඩන්නේ. හරක් හදන්න ඕන නැත්නම් පාඩම් කරපිය කියනවා නේ. හරක් ඕන තරම් රටේ ඉන්නවනේ දැන්. Right. How do we gather? So we must know the functional requirements, non-functional requirements, domain requirements, or otherwise the user requirements and system requirements. So there are some conventional techniques and non-conventional techniques. I will first give you the conventional techniques. So the number one is interviewing. Another approach is questionnaire. Right? We can study the existing documents. We can go and see the system, how they work. Right? So that is observation. Or sometimes we call it ethnography. We can look at similar systems, analyze similar systems. All those are going to help us. Okay. And even we can do some prototyping as part of the gathering. Actually, the prototyping is going to help this requirement gathering. Okay. It's not really a gathering, it's helping. And more than this, the most important thing, I'm not saying that these are bad. We use these even today when we need. But now our main approach is, can someone tell me what is our main approach? How does the modern software development gather requirements? Especially in Agile. So it's called joint requirement gathering or joint development also. So that is, we have joint meetings. So we get together and discuss what are the requirements. That is very effective. Okay. Right. So let's take one by one. Interviews. So interviews means we go to, in software development in old days, we had a role called system analyst. It's no longer used. System analyst. So the system analysts go to the key people and interview. Say that if it is a high level system, maybe starting from managing director, the relevant functional managers like finance manager, if it is finance related system, then accountant and relevant people. So go and interview them separately and gather the requirements. Note down. So that is interviewing. In interviewing, we can ask different type of questions. So there are open questions and closed questions. Open question, closed questions. Open questions means we just sort of providing the answers, so possible answers, and we just take what is your answer. But open questions are we just get their opinion, right? Very openly. And of course, there are some challenges in interviewing. The main challenge is getting their time, because we have to get their times separately. Okay. And also we need a very good someone who has a lot of communication skills to do this. And again, if there's a conflicting situation, you have to again get back to the other person and clarify. So there are some issues also. But it's very effective because you can dig into the requirements. If it is not clear, you can at that time clarify it. Right? And you can go into the details where you need it, asking some follow-up questions. Okay. Right. So the next one is questionnaires. So questionnaire is a written document where you send set of questions and you get the feedback or the answers. Okay. So the questionnaires are used when you want to get feedback or requirements from multiple people, not just one. Right? So you can send the same questionnaire for 10 people and get their answers. So the main advantage is then you don't have to spend a lot of time going after individuals. And also the people who are answering the questionnaires also, they can do it at their own time. They don't need a dedicated time slot. But the main disadvantage is this is not interactive. We can ask only predefined set of questions. And also if there are unambiguities, etc., we don't have that opportunity to dig into that. And also usually when you send a questionnaire, unless it is sort of a very formal, there's a very low feedback rate. People tend to not to provide you the answers. Right. Another thing is you can study the documentation, procedures, policies, etc. Or if you have a system already, you can study the current system's documentation to get a feeling of what are the business flows, etc. So similarly, you can analyze similar systems. Say if you are developing a accounting system, there are plenty of accounting systems, right? There are some demonstrations available. Their documentation is available. So why don't you just have a look at it? If you are developing this for the first time, especially. So that is analyzing similar systems. In your final year project, we call that part as literature review. Okay. You analyze similar systems and get a feeling of what are their features, what are their strengths, weaknesses, because you want to develop something better than their systems. And of course, you can go and have observation on how the process is happening. So that is extremely important. If you are developing a passenger check-in system for the airport, you must go and see how the process is happening. So what are the different places? Because otherwise you combine two functionalities together in the development. But in the airport, these two things are happening in two different places. or you develop it as separate things, but in reality, both are happening in the same place, same time. Now they have to go to two different screens to do that, whereas they are expecting that those two are in the same screen. So why do you develop it like that? Because you have no idea what is happening in the real environment. So that is very important. I'm not saying that every team member must go there, but at least the people who are taking those key decisions, design decisions, they must go and see how the things are happening. Especially if it is a domain which is little bit unfamiliar to you, like observations. Right. So then we can use prototyping. That is especially when the requirements are not very clear. We can create a prototype and verify then and there. And also when the customer is also, the client is also not very clear about the requirement. Sometimes you just want to explore some ideas, some new business opportunities, and develop system for those opportunities. So then you have to explore requirements together with the customer. So that is again a place where prototyping is really handy. We can keep making prototypes and see whether we can agree on the requirements. Okay. So all those techniques I use in varying degree, depending on the system we are developing. Okay. But these days, while we are doing these things in a certain extent, what we prefer most is, so we have sort of a joint requirement related meetings, discussions. It's sort of an extension to the interviewing, but interviewing is one-to-one. Whereas if we can get all of them together as much as possible and have a common discussion, it's very productive. And of course, we must have our development team or the key members of the development team also there. So then if there are conflicting requirements, we can clarify those because all the parties are there. If something is ambiguous, we can get it clarified, though the others also can help. Right? If ambiguity is for any of the development team can raise that question. So that is very productive. It's extremely productive approach. And also while we are doing the discussion, the development team can develop quick prototypes. So prototypes are not technical things. Even we can sketch something and show it and ask whether is this kind of a thing is going to suit you. It's very, very productive. And in agile environment, because requirement gathering and understanding is also sort of ongoing process, we have these meetings regularly. Of course, if you can't participate everyone, so remember in agile, we represent one person on behalf of all these stakeholders. We call them product owner. Remember, product owner has the product vision. He is the go-to person for requirements. He is there to clarify, verify. But anyway, product owner can ask other stakeholders to join these discussions, especially product grooming discussions. Okay, so likewise, you have to relate it, how these things happens in good old days of waterfall, how these things change gradually in iterative approaches, and now how these things are done in agile environment. So we are not saying that we are not doing this, but we are doing more of this. While we go and observe and study existing systems day to day, but our main approach is this. Okay, right. So now we are done with how to gather requirements. So any questions? So this is done. So you must have a very solid understanding. Right. So then next we can move on to the analysis. Analyze. Right. So what is mean by analysis? Now, in your next semester, you have a subject called Object-Oriented System Analysis and Design, OSAD. In your old syllabus, in semester 2 also, the old syllabus students had the subject called System Analysis and Design. Now it is replaced with the software engineering subject for you, because it's no point doing 2 times the same thing, right? Similar things. Right? What is mean by analyze? Analyze. විශ්ලේෂණය කරනවා. So there are so many analysts. ක්‍රීඩා විස්තර විචාරකයෝ ඉන්නවා. ඒගොල්ලෝ කරන්නේ analyze කරන්නේ. Weather analysts ලා ඉන්නවා. Financial analysts, so they analyze the stock market, forest market. There are political analysts, දේශපාලන analyze කරනවා. මෙහිම තමයි මේක වෙන්න හදන ඉස්සරහා ඡන්දේ මෙන්න මෙයාට තමයි chance එක වැඩියෙන් තියෙන්නේ කියලා analyze කරනවා. Economic analyst, social analyst නේද? සමාජ විශ්ලේෂකයෝ ඉන්නවා. විශ්ලේෂණය කරනවා. සමහරවිට ඔයගොල්ලෝ දැකලා තියෙන චූටි මල්ලි පොඩි මල්ලිගේ වීඩියෝ එකක් තියෙනවා සමාජ විශ්ලේෂක කියලා. ඊළ බලන්න සිස්ටම් ඇනාලිසිස් කරන අය. සමාජ විශ්ලේෂණය කරනවා. YouTube එකට ගිහලා බලන්න. එයත් ඇනලයිස් කරනවා. මේ ගෙදර පොඩි ළමයෙක් ඉන්න පුළුවන්. හරි. එයාට අවුරුදු මෙච්චරක් වෙන්න පුළුවන් කියලා කියනවා. කවුද? චූටි මල්ලිද කොහෙද? හරි. Right. So what is analysis? So analysis means basically we try to understand. So in order to understand, now we have gathered and we have clarified, verified, blah, blah, blah. And remember, analysis is not done after gathering. So while gathering also, we are doing the analysis. So these tasks are not sequential. Okay. While we are in a joint requirement meeting, we are doing analysis in our mind, and we are doing certain document modeling and documenting, and sometimes we can do verify and validate also at that time. So therefore, don't think that these are sequential things. So these things can happen, right, simultaneously. Right. So what is analysis? So there are few things we can do. And combination of these things we call analysis. One thing is we can break it into aspects. Break into aspects. අපි මේ system analysis කියන subject එකත් අපි analyze කරන එක තමයි මේ කරේ. ඉස්සර කැඩුවා. නේද? So we break it into why, what are the challenges, what are the tasks, what are the types. So likewise, when there's a requirements also, we can break it into aspects. Okay, what are the functional requirements related to this? What are the non-functional things? Do we have any system requirements? Do we have any domain requirements? So break it into aspects when you take a particular requirement. So that is part of the analysis. Then we want to, once we break it, we want to see how they are related. You break it and see how they are related. Right? We know that when you say water, we know that it is H2O. You break it into hydrogen and oxygen, and then we say how they are related. So we know that they are related like this. I hope that is the way, if I can remember correctly. Okay. So then benzene, right? So we know that, I don't know what is, right? Oxygen and hydrogen, I don't know, right? So then this is how they are related. It is not the way water molecule is related, oxygen and hydrogen. And we know that sodium chloride is sort of a different arrangement, right? It's a lattice structure. Right? So how they are related, or relationships. So we break it into different parts, aspects, components, and now we interrelate those. So this is what your studying is also, okay? Then we identify what are the generalization and specializations. So what are the general cases? Is this a special case of that? Okay. So that is also very important, especially in object-oriented analysis and design. So inheritance is one of our main weapon. Okay. So are there any special type of orders? Yes, there are some special type of orders, express orders. We want to finish it in one day, and then the customer will talk. But the customer has to, or your client is going to talk. Then he will say, okay, yes, there's express order, but customer has to pay 5% extra. Yes, there are some special payment methods. We accept both card payments and check payments. So generalization and specialization. So we have special customers. We call them platinum customers. So that is generalization and specialization. So we have to identify those things. So we break into aspects and components. We identify the relationship between those, and we see what are how the things are generalized. What are the general aspects? What are the special aspects? So that is what is meant by analysis. Okay. So doing that is understanding these things in using these concepts or techniques is called analysis. Okay. So that is what system analysts are supposed to do. So that is what any other analyst is also doing, not only software related analyst. Right? If you take someone like a cricket analyst, විශේෂඥ විස්තර විචාරකයෙක් කියලා match එකට කලින් analyze කරන්නේ. So they break it into different aspects. So they take the weather, they take the ground condition. So they take the team composition. Okay, so then they take things like the morale of the team A versus the morale of the team B. Team B එක මේ දවස්වල මානසික වැඩිලා ඉන්නේ බීඩි ගහලා. හරි බීඩිකාරයෝ ඉන්නේ. So likewise they can analyze. Right? So they will say, okay, so there's a dew factor in the evening. So that is analysis. So they break it into different aspects. And they see the relationships also. Right? So they can analyze the batting and bowling separately and fielding. So likewise they break it. So that is what analysis. Analysis එක කරගන්න තරම් බුද්ධිය තියෙන කෙනෙක් වෙන එතනට ගන්න. ක්‍රිකට් ගාව හැමෝටම එන්න කියන්නේ නැහැ නේ එක්ස්පර්ට් කියලා විදියට නේද? ඒවා ඒ විදියට දකින්න කෙනෙක්ට තමයි ගන්න. ක්‍රිකට් ගන්න හැමෝටම සාමාන්‍යයෙන් බුද්ධිය තියෙන්න ඕන. ටෙස්ට් ටීම් එකේ ඉන්නවනම්. නමුත් සමහරුන්ට ඒක වැඩියෙන් තියෙනවා. ඒ වැඩිම තියෙනව තමයි නේද? දැන් මහේලජාවර්ධන අරගෙන දාලා තින්නේ කන්සල්ටිං කෝච් කියලා නේද? ඒ කියන්නේ එයාට ඒව ගැන හොඳ අයිඩියා එකක් තියෙනවා. ඒ කියන්නේ එයාට ලොකු ගාණක් දීලා හැමදාම මුම්බේ හරි මොන හරි ටීම් එකකින් ගන්නෙ. මොකද එයාට හොඳට ඇනලයිස් කරලා අනිත් ටීම් එකත් ඇනලයිස් කරලා එයාට පුළුවන් ස්ට්‍රැටජි හදන්න. ඩිසයින් කරන්න ඊළඟට මැච් එක ගහන්නේ මෙහෙමයි කියලා. ටීම් එකට හෙල්ප් කරන්න. So these are very, very, very interesting topics. Okay, so this is what the intellectuals, the professionals are expected to do. Not just take a piece of paper and okay, write some code. හරි දෙකයි පණේ වැඩ කරන්නේ නෙමෙයි අපිට professionals ලා ඕනේ, engineers ලා ඕනේ. හරි. ඊට වැඩි ටිකක් නෙමෙයි බොහොම සීරියස් විදියට ලෝක යමක් දිහා බලන්න පුළුවන් නේද? සීරියස් වැඩක් කරන්න පුළුවන්. ඔය නිකන් කුරුටු ගගා ඉඳලා බොරුවක් කළා නේද? කාලකන්ණියෙක් වගේ කීයක් හරි හම්බ කරන එකට එහා යන්න පුළුවන් කෙනෙක් අපිට ඕන. Right. So that is analysis. So next we have the modeling. Now remember we have separate topic called modeling, system modeling. Right. So what is mean by modeling? So therefore let's take it separately. So what is a model? First of all, you must know what is a model, because modeling is making those models, right? So what is a model? So can you give me examples of a model? Examples. So modeling is, or model is, abstract representation. Model is abstract representation. It represents a concept in abstract manner. Right? It represents concept in an abstract manner. So what is mean by abstract? We discuss these things, okay? When we are doing programming, abstract means minimum essential. අත්‍යවශ්‍ය අවම. Okay. අත්‍යවශ්‍ය අවම. ඕක අපිට කරගන්න බැරි හන්දනේ මේ මෙච්චර දුක් විඳින්නේ නේද? අවම දේ අත්‍යවශ්‍ය දේ රිප්‍රසන්ට් කරගන්න බැරුව හැමදේම කරන්න හදනවා. නේද? ඔයගොල්ලෝ දැන් ලෝකේ තියෙන කොම්ප්ලෙක්ස්ම කොඩිය තියෙන කාටද? අපිට. ජපනයේ කොඩිය තියෙන මෙහෙම රවුමක් විතරයි. හරි. තව ජර්මනි වගේ කොඩියක මෙහෙම ඉරි තුනක් තියෙනවා. නේද? නැත්නම් තරු ටිකක් තියෙනවා. රතු පාටේ තරු ටික. අපේ කාට මේක සිංහයා කියලා එඩිටරයි කියලා පෙන්වන්නත් ඕන. මු තිරිසනෙක් කියලා පෙන්වන්නත් ඕන. මු ධාර්මිකයි කියලා පෙන්වන්නත් ඕන. නේද? මුට තේජස තියනවා කියලා පෙන්වන්නත් ඕන. මු හිඟන්නේ කියලා පෙන්වන්නත් ඕන. ඊට පස්සේ මෙතන මුස්ලිම් අය ඉන්නවා කියලා පෙන්වන්නත් ඕන. දෙමළ අය ඉන්නවා කියලා පෙන්වන්නත් ඕන. ඔය හැම මගුලම මේක ඇතුලේ පෙන්වනවා. ඊට වැඩි හොඳ රචනයක් ලියවනවා. කොඩියක් හදන්න නැතුව අපේ උන්ට තිබුණේ මොකද්ද? රචනාවක් ලියලා ඒක print කරලා දෙන්න. මොකද abstract thinking නැහැ. හරි. සියලු දේ පෙන්වන්න බෑනේ මේකද නේද? So model is an abstract representation. හරි. අනිත් මිනිස්සු මේ ලංකාවේ කොඩිය දැක්කම අනිත් මිනිස්සු බඩාලාගෙන hina වෙනවා ඇති. මු මිනිස්සු වෙන්න බෑ කියලා. හරි. මිනිස්සු වෙන්න බෑ අමුතුම සත්තු జాතියක් කියලා. මේ වගේ දෙයක් කොඩියක් හැදුවේ කොහොමද කියලා. ඔකට දැකලා නේද? අඩු ගන්න වෙන රටවල් ඒක වෙනස් කරගෙන යනවා ටික ටික. තමන්ගේ ප්‍රශ්න. Right. So abstract means minimum essential. So you represent it as a minimum essential thing. Okay. So that is modeling. So when it comes to modeling, you can model different aspects in different models. So we can separate aspects. Now you can remember here we break into aspects. So now those aspects we can model separately. Right? So different model for different aspects. Right? So data side, you have ER diagram. The process side, you can have context diagram, data flow diagram. So that is modeling. Right? So we are going to discuss more about modeling when we are doing designing, right? Object-oriented modeling, how the classes are related with each other, class diagram, how they communicate by message passing, sequence diagram, how they change their state diagram. So different aspects can be modeled in different diagrams. Because if you try to understand all the aspects together, it's complicated. But if you model separate aspects separately, it's easier to understand. That is one of the key idea behind modeling. You model different aspects separately. And it must be abstract. It must be minimum essential. මේ ඉගෙන ගන්නවා කියන්නේ ඔයාගේ මානසික වෙනසක් වෙන්න ඕනේ. ඔයාගේ ආකල්ප වෙනස් වෙන්න ඕනේ. ඉගෙන ගන්නවා කියන්නේ මොන හරි කටපාඩම් කරන් ගිහලා ඒක වමනේ දාලා එන එක නෙමෙයි. හරි. ඔයාගේ ඩිග්‍රියත් එක්ක ඔයා ආකල්පමේ වශයෙන් වෙනස් වෙච්ච අර ගොබ්බ සංස්කෘතියෙන් එළියට ආපු මුග්ධකමින් එළියට ආපු නේද? ප්‍රොෆෙෂනල් කෙනෙක් වෙන්න ඕනේ. ගොම් වැඩ කරන්නේ නැති මෙලෝ ඵලදායීතාවයක් නැති හරක් වැඩ කරන්නේ නැති ආත්ම ශක්තියක් තියෙන ආත්ම අභිමානයක් තියෙන එක එකගේ පස්ස පැත්ත යන්නේ නැති වැඳ වැටෙන්නේ නැති හතර ගාතේ දාලා දකින්න මගුලට නේද? ඒව කරන්න තමයි මේකට චින්තනය කරන්නේ. So you must be able to separate out things, see the relationships, see generalization and specialization, and also when it comes to complicated things you must be able to model those. So get the essential and make different model for different aspects so that you can better understand. Okay. So there are so many examples we can give from different fields. If you take something like electrical engineering or whatever, right? Electricity field. So you know that we have circuit diagrams, capacitors, right? So many things. So you can have bulb. So that is a model. This is not the actual circuit. It's a model. It has the minimum essential of what we are going to build. It's actually designing model. Right? If you take chemistry, so this is a model of the water molecule. This is a model of benzene. Right? It's a model. And we have the model of the atom. In your O-level, you learn one model, something like this. And in A-level chemistry students, they know that there's something called S, P, and D. It's a model. So modeling is one of the main weapon in understanding complex things. Right? Understanding complex things. So we also do that. So that is why we have use case diagrams. We have the data flow diagrams, context diagrams in requirement analysis. And designing also we model. Like class diagrams, sequence diagrams, etc. So unless you have a feeling about this, don't think that your A for your software engineering is going to make you, right? Software engineering වලට ඒ ගත්ත හරක් අපි ඕන තරම් දැකලා තියෙනවා. සබ්ජෙක්ට් එකක් තේරිච්ච නැති. හරක්. හරි. ප්‍රොජෙක්ට් එකක් කරගන්න බෑ. ගිහිල්ලා වැඩක් කරගන්න බෑ. එහෙම ආත්ම ශක්තියක් නැහැ. වැඩක් කරගන්න. කටපාඩම් කරන් ගිහිල්ලා හරි. මම අරලා එනවා. Right. So that is modeling. That is modeling. Right. Now you know what is modeling. Right. So then we have to document. So again, in traditional approach, that is waterfall approach, and also in other approaches like rough and iterative other approaches, there was a lot of emphasis on documentation. Lot of emphasis. Document. නේද ඉස්කෝලේ වල මතක නේද රචනා ලියන්න පිටුවක් මදි පිටු දෙකක් ලියන්න උත්තරේ දිගට ලියන්න මතකද ඉස්කෝලේ වල දැන් නටන නාටකම් මම හිතා තාමත් ඒ නාටකම නටනවා හරි ඇයි මේ උත්තරේ ලකුණු 5න් 3ක් දුන්නේ ඔයාව ඉස්සර ලියලා මදි තව ලියන්න ඕන දිගට කරපිය but that is the old approach. Do a detailed documentation, but the new approach is document only the essential. So we are not saying that don't document, but just the minimum documentation. So in waterfall approach, this document is called SRS, Software Requirement Specification. It's a formal document. But in agile development, we just call it product backlog. It's just Excel sheet. And we have user stories. User stories are you can even write it in a card. So the documentation involve all the models we prepare, like use case diagrams, context diagrams, etc. And any other additional notes, etc. that we make. And it has to be very informal, right? Because when you become formal, you waste your time. Formal කියන්නේ කාලකන්නිකම. Informal කියන්නේ ඒගොල්ලෝ හරි productive. ඒගොල්ලෝ හරි productive. ඔක දෙකෙන් software engineers ලා නේද? දෙනිමයි t-shirt එක ගහගෙන තමයි වැඩට යන්නේ. දෙනිමයි t-shirt එක ගහගෙන ගියේ නැහැ කියලා මොකක් හරි අඩුපාඩුවක් තියෙනවද? නැහැ කිසිම අඩුපාඩුවක් නැහැ. හොඳ බුද්ධිමත්. කෝට් එක දාලා කබාය දාලා නේද සමහරව අර ඉන්න පාර්ලිමේන්තුවේ එකෙක් ඉන්න ඔළුවේ පාපිසකුත් දාගෙන ඉන්නවා ඊට උගම ඒගොල්ලෝ ඉතින් ඒවා මරු කියලා හරි so we have to do the minimum documentation okay so you learn that in agile you have a subject called agile development right in your next year we are going to learn agile philosophy in detail okay so idea is document the minimum essential. And part of that document is already there are your models, right? And maybe a little bit additional things. Okay. Right. So once you document, because we need some sort of a documentation in case there's a conflict of interest, Okay, or people may forget things. Right? But when we have very small iterations, we tend not to forget, right? Because you can't forget something within 3 weeks. But yes, in waterfall, you start somewhere January and somewhere December. So therefore, you have to do a lot of documentation, because people gather requirements in January and design it in April and develop it in August. But it is no longer the case. Right? We gather requirements and evening we do the designing and development. Right? Right. So finally, we have to do the verify and validate. So those requirements we can verify and validate in the meetings itself, and also we can give our models, show our models to the customer or the product owner and verify. It's very important, because there's always, we are humans, right? We can make mistakes, we may misunderstand something. So our model is our understanding of their requirements. It's our understanding of their requirements. So therefore, why don't we show it to them and verify it? So then they will say, okay, this is correct. No, this is not the way I explain it. This is not I thought. So then we can modify it. So it's very important to verify and validate. We can verify and validate by showing our models, like use case diagrams, etc. And also, if still it is ambiguous, we can even create a prototype and show. So what is the difference between model and prototype? Your use case diagram is a model. Your data flow diagram, context diagram is a model. Your class diagram is a model. But prototype is a working model. Working model means it's more closer to the reality. Maybe you just create a screen using HTML, right? So experienced developer can develop a screen within half an hour, 15 minutes. Simple screen. There are some tools also, drag and drop, and you can create wireframe tools, etc. So that is very important. Verify and validate. Okay, right. Right. Now we are going to discuss about this modeling little bit more related to analysis. Okay, what are the analysis models we have? Now remember, we can do analysis in two ways, depending on whether we are going for structured software development or object-oriented software development. So structured analysis, object-oriented analysis. Okay, structured analysis. Then of course, if you are doing structured analysis, you are supposed to do structured design and structured programming. If it is object-oriented analysis, you can go for object-oriented design and object-oriented programming. So these days, more than 80% of the software is developed in this way. So only about, okay, even less than 20%, maybe I will say it's about 10%. Okay, let's say 20% of the software is developed in structure. Very rarely. Very, very, very rare. Sometimes it's object-oriented, maybe certain aspects we just think in terms of structure. Okay, but overall it's pretty much object-oriented, unless it's a small website or something like that. Okay. So first, let's discuss how do we analyze the requirements using structured way. Right? How do we analyze requirements using structured way? So if it is structured analysis, so that is, remember I told you that earlier you had two subjects, semester 2 system analysis and design. Actually that is structured system analysis and design, and semester 3 the object-oriented system analysis and design. Now they have removed the structured or the normal system analysis and design, and they have kept only object-oriented analysis and design. Okay, because more and more we are using object orientation. Okay, right. But anyway, still we use bit of structured analysis and structured concepts while we are doing object-oriented development. So in structured, we know that we think in terms of control structures. Right? Everything we look at it as we have data, process, into information, process. How do we process? By applying operations. When you are applying operations, we use control structures. It's very simple thing. Right? So software development is not a complex thing for someone who has a very good, clear mindset without any bullshit. Any එක garbage, kai katandara, වැල් වටාරන්න නැති කෙනෙක්ට software development කියන්නේ ඉතා සරල දෙයක්. දැන් අපිට හන්දට යනවා කියන එක නේද? රොකට් එකක් යවනවා කියන එක ඉතාම කම්ප්ලෙක්ස් වුණාට ඇමරිකාවේ මිනිස්සුන්ට ඒක කම්ප්ලෙක්ස් නෑ නේ. මේ මිනිස්සුන්ගේ අපේ මිනිස්සුන්ගේ වැල් වටාරන්න තියෙන හන්දේ හාවා ඉන්නවා, සස ජාතකයේ දිනවා. හරි හන්දේ ඕල්මන් ඉන්න පුළුවන්. එහෙමත් එවුන් ඉන්නවනේ. ඒවට බැඳගෙන ඉන්නවනේ. හඳ පේන දවසට ගිහිල්ලා විශේෂ වතාවක් කරනවා. නේද? සමහරුන්ට හඳ පේනකොට පිස්සුත් අද වෙනවා. මේ මිනිස්සුන්ට එහෙම ගන්න නෑ. මේ මිනිස්සු ගිහිල්ලා හඳට යනවා නේද? චන්ද්‍රිකා යවනවා, අඟහරු තරණය කරනවා. ඒ මිනිස්සුන්ට ඒක සරල දෙයක් තියෙනවා. අපිට ඒක ගැන තියෙන ලොකු වැල් වටාරම් ගොඩක්. So therefore, if you have a very clear idea about software development is easy. Okay, right. So its structured approach means you process data into information. So how do we process? We apply operations and we use control structures. And also, if there are same thing we are doing over and over, we can put it into methods, right? Put it into methods so that we can reuse it. That is how the structured software developers think. Now, when it comes to analysis, still we are in the analysis side. Remember, we have the data and process. We have to model data and process. We have to model data and process separately. So that is why we call it structured approach is a process plus data approach, P plus D approach. We separate the concern and we look at it in a two separate manner. So then at the requirement analysis stage, you have to analyze and model data. So how do you analyze and model data? Can someone tell me how do we analyze and model data? Because we have already done that in our database subject. So that is where we have ER diagram. Right? Remember ER diagrams, we discussed the business ER diagram, then the conceptual design, then the physical design. So this is all about that conceptual ER diagram. Something like this. Identifiers, right? Composite attributes, multi-valued attributes, associative attributes, blah, blah. So that is what we do. We understand the data aspects of a system. It's requirement analysis. We understand the current system, the expected system. So the main diagram or main model we use in modeling data aspect is entity relationship diagram. Okay. So that I am not going to explain further because we have already done this in the database subject. Okay. Right. So then what about the process? So when it comes to process side, we have first, remember I told you when we are analyzing, so we want, I think I forget to mention that part. When you're analyzing, it's very important. First, you look at the big picture. So I forget that. Big picture. So that is the starting point. So when you analyze something, you first look at the big picture. Then you break it into component aspects. Now you look at the relationships and how they are generalization, specialization. Okay. So when it comes to process, right? When it comes to process, we look at the big picture of the process by using something called context diagram. Context diagram. මොකද්ද මේ context කියන්නේ? Context එක කියන්නේ සන්දර්භය. Big picture එක. මිනිස්සු කියන්නේ නිකන් ඔය මාචාර්යවරු එහෙම නේද? මේ සන්දර්භය යටතේ අපි මේක විග්‍රහ කරන්න ඕනේ කියන්නේ. ඒ කියන්නේ මේ context එකත් මේක analyze කරන්න ඕනේ කියලා කියන්නේ. Right. So context diagrams are used. So now in your old syllabus, we had these things in a system analysis and design. Now in your new syllabus, it is not there. But anyway, I will just mention because otherwise there's a small gap. Okay. So they have removed it. They have not even mentioned it in your software engineering subject. So, but I'm going to just show you. So context diagram is you look at your system as a black box. You don't look at the what is happening inside your system. Then you look at the external entities and how they interact with your system. That's all. So that is what is meant by big picture. You don't go into the detail. So you look at the system as a black box, your system, and those are the external entities, right? External entities, not the internal entities. It's not your managers and staff members. This is maybe customer, maybe supplier, maybe bank. So how they interact with your system. So that is called context diagram. And in all the interactions, we put it into one diagram so that we have the big picture. Okay. For example, I will just show you a sample context diagram. Context diagram, say for library, very famous example. I don't know whether I get a good one, but at least some sort of a. So not a very good one. So you can see student. Here they have taken librarian and admin staff also as external, but usually we don't show them as well. So borrow book, get the book list, right? Blah blah blah. Okay, that is not a very good one. Let's see whether we have better one. This is not a context diagram. Let's say context diagram. Forget about this. Right. So it's something like this. Customer management. Right. So this is your system and how they interact with your system. Okay. How they interact with your system. You can see customer service, credit card authorization company, accounting, and this is your order process system. So that is called context diagram. Okay, context diagram. Give you the big picture. So now you want to go into the details of the, remember this is process. Your data is already modeled using ER diagram. So that is your first one, context diagram. Then you go into the details, identify the components, subcomponents, how they are related. Remember, so these things are interrelated, right? So now you want to see, break it into aspects, how their relationships, etc. So that is where you have data flow diagrams. So that is why we have, after context diagram, now we have data flow diagram. Data flow diagrams. So there, now it is, in context diagram, your system is a black box. In data flow diagram, your system become white box, so glass box. Now you can see the subcomponents, you can see the data sources. Okay. So let's take an example, because it's not directly in your syllabus, but I don't want to keep some gaps, right? When you go to the industry, data flow diagram and that something like this. I can't see. It's not very clear, right? Simple. You can see that now you can see still entities are there. Customer, supplier, entities are there, but now you have the sub processes: order, clothes, generate reports, order inventory. Now your system is a white box or glass box. Now you can see the internal sub processes, and also now we expose the data sources. right? Data stores or files or whatever. Okay. So this process will write to the data source, and this process will read that data. So likewise, now you are giving more information. So that is data flow diagram. If a particular data process or if a particular process, sub-process, you need more information, you can go for another data flow diagram for that one. So then we say it's a level 2 data flow diagram. So likewise, you can go into hierarchy. Right? So if you want to show a lot of information about this complex process, you can go for another data flow diagram, but only showing these. So now the person can gradually dig into the details. Okay. So context diagram, data flow diagrams, and data flow diagrams, you can go into levels, level 1, level 2, and therefore sometimes we call context diagrams as level 0 data flow diagram. So data flow diagrams can go for data level 1, level 2, etc. depending on the complexity. Usually just we need the level 0 DFT or context diagram and just one level 1 DFT. Okay. Right. So that is how the requirements are modeled in structured software analysis and design. Though this is not directly mentioned, I just explained it, okay? Because I don't want to have gaps with you. Now then, how do we model the requirements in object-oriented approach? Remember, in object-oriented, we don't break it into data and process. Like we don't break it into data and process. No, we look at it as a whole. Look at whole things as one. Okay, we look at whole things as one unit. So in object orientation, when we are requirement gathering or analysis and modeling, what we use is, we call it UML diagrams. In object orientation, we call them the UML diagrams. So that is where you spend most of your time in your object oriented SAB subject, learning about these UML diagrams, unified modeling language diagrams. So the diagram that we use is use case diagram. Use case diagrams. Okay. So there it's different thing where you represent the system and you look at the use cases and you have the actors and how these actors communicate with the use cases. So it's a different way, and it's even a simple way of modeling. So the professionals make things simpler. The non-professionals, takkadi neda. ඒගොල්ලෝ මේක කම්ප්ලෙක්ස් කරනවා. කම්ප්ලෙක්ස් කරන ධර්මයට ඒගොල්ලන්ට වාසි. ගසා ගන්න පුළුවන්, හොරා ගන්න පුළුවන්. සිම්පල් කරන ධර්මයට මිනිස්සුන්ට වාසි. අලුත් දේවල් ඊට වැඩිය ඇඩ්වාන්ස් දේවල් අට හම්බ වෙනවා. ඩෙවලොප්මන්ට් කොස්ට් එක අඩු වෙනවා. Right. So I will be explaining you the use case diagrams elements when we are discussing the now we are moving to your VLE, your university note, and I will explain few concepts related to how the use case diagrams are made. Okay, right. So let's get back to your note. Right. So now we are pretty much done. Right. So now I am moving to your note. Okay. So this is our note actually. You can go through our note, which is pretty much based on your university note. Okay. Then of course you have to go through your VLE note also, because when the exams are nearing, you have to go through your VLE notes as well. So this gives you a big idea about what is a context diagram, what is data flow diagrams, little bit more detail. You don't have to worry too much about these things, right? So if you can understand the stuff mentioned in your syllabus, that is good enough. Okay, but class diagrams, use case diagrams, you have to, okay, understand. Comes to use case diagrams, so that is the main way that we use to model requirements in object oriented system analysis and design. Okay, so there are a few concepts. Okay, so we have mainly, you have actors, then you have use cases. So actors are represented like this, use case is represented like this. So this actor can be human actor or it can be a system. Whether it's a human or system, we just use the sticky figure, right? Sticky figure, right? So you don't have a separate symbol for system actors. So system actor means other system accessing your system. Okay. So then you represent your system as a sort of a system boundary like this. So then you have the different use cases which are initiated by actors. Something like that. Okay, you can draw other side also if you're running out of space, and sometimes something like that. Okay, so then anyway, we are going to learn about use case diagrams in detail in your semester 3, but they have added few things into your note as well. So therefore, I'm just showing you few things. Now there's a relation or interactions between actors and use cases. Then there are some connection between use cases, connection between actors. Okay, so let's start with connection between actors or relationship between actors. So you can have a situation like this. One actor inherit from another actor. Right? Say this is use case diagram. Say this is a use case. Say this is make payment. Make payment. So usually use cases will have verbs, make payments, cancel order, right? So that is convention we use. Say this is a customer. Say credit, someone having a credit card for a bank, okay? Say this is a customer. Now assume that we have people with platinum customers or privileged customers, right? Platinum customer. So platinum customer can do whatever the customer can do. So therefore, yes, platinum customer also can make payment. You don't have to draw it because it's inherited. But assume that platinum customers can claim bonus. Right? Claim bonus. That is normal customer cannot do. The platinum customer can do make payment because it inherited, and it can, they can do claim bonus as well. So this is how you show inheritance between actors. Okay, so there is one type of relationship. So this is also a relationship. This is the communication, right? Or it can be both way. If both way, you just don't draw this. So that means two-way communication. Right? But this is open arrow. This is a closed arrow like this. Inheritance. This is communication or no arrow. That is bidirection. Right. So then there can be, now this is a relationship, inheritance, this is communication. Then there can be relationship between use cases. Right. So between use cases, we can have two main relationships, that is includes and extends. Okay. So let's take an example of include. Say this is make order. This is make payment. Say both can be done by customer. Now assume that when you make order or when you make payment, we have to log it. That means write to a log file. Say log transaction. So when you make order also, you have to log it. You have to make payment. Every time you make an order, you have to do it. Mandatory. So then you can do something like this. And you can say include. Here also you can say include. So that is called include relationship between use cases. So include means mandatory. Whenever you do this, you have to do that. Include. So likewise, we can make it simple. Otherwise, here also you have to say log transaction. Here also you have to say now. You just do it once and you include to other things. So that is called include relationship. Include goes from the main use case to the including use case. So then there's another type of a relationship we show in use case diagrams. So that is mandatory. Okay, include. Then we have optional. Say customer. Say make payments. Assume that when you are making payments, optionally, you can claim bonus, not always, in certain cases. So then you can say it's a claim bonus. Now it is not include because not all the time, in some special situations. So then you can roll like this towards the main use case and you can say extends. So this is include relationship. Main use case towards the include one. This is extends the optional use case towards the main use case, and it's a dotted line, open arrow dotted line, and you use these are called stereotypes. So those are just concepts or techniques we use to document model. And finally, there's another possibility. Say this is your main use case, say make payment. So maybe that make payment can be either check payment or make check payment and make cash payment. So special cases. Okay. Or make check payment and make card payments and make cash payment. That is, again, we use the same symbol as we use actor inheritance. But this is inheriting between use cases. So that is called inheritance of use cases. This is inheritance of the actors. Okay. Right. So actor is just a role. It's not Nimallo, Sunillo, Mr. Perra. It's cashier, customer, manager, etc. And we have to make it very abstract, right? Sometimes when you look at the use case diagram, you get upset because it's so simple. So some people cannot tolerate that. I can සරල බව දරා ගන්න බෑ. මොකද ඒගොල්ලන්ගේ ජීවිත හරි complex. සරල බව දරා ගන්න පුරුදු වෙන්න වෙනවා engineering කරනවා. Right. So that is how you draw use case diagrams. And of course, here you have only small details. So if you need more details, you can go for, there's something called use case descriptions in a tabular format. You can give the additional details. Okay. So you have to go through the note to get, if you want to understand the subject. Okay. If you want to just pass the exam, maybe going through the VLE note is good enough. But if you want to pass the exams and be a professional who can go and work, yes, go through our notes as well. Okay. Inheritance, extras. So this is use case narratives. If you want to give more information about more details, right? Something like that. So it has the use case name, use case precondition, post conditions, what are the flow of activities, right? And what is the outcomes, alternative flows, error flows, you can show. Okay. Right. So documentation I explained. So the validation is basically you show it to the customer, our models and our documents, and get his or her approval. So in formal development, it's very formal process, but in agile development, it's very informal process. So we want to make things informal, right? Formalism, formality is a productivity killer, right? Informal things are highly productive and it's very natural, right? It's very natural. Informal things are artificial, right? Contract is artificial. Mutual understanding is very natural. So that is why we are learning more and more agile development. Okay. It's something like marriage is artificial, love is natural. Right? So if you don't trust, you marry. If you trust, you love. Same thing, right? So that is why we have less documentation, less formality. We go for more and more informality, mutual understanding with the customer, etc. Okay. So therefore, requirement validation also we now do it in a very informal manner, right? That is why the product owner is part of the team, right? Rather than product owner is outside the team. So it's our product, right? It's our product that we are developing. Right? It is not your product we are developing. Okay, so then we have less and less need for documentation and uh, formal validations, etc. But anyway, we need some sort of validation, right? That mutual understanding must be there, right? So then I told you there are some challenges. Now we basically understand how to tackle the complexity by analyzing modeling, right? How to tackle the ambiguity by model and showing it, or by creating a prototype and showing it. Have proactive, interactive discussions rather than good old ways of questionnaires and other things, which are very passive, right? So another very big challenge we are having is when the requirements are changing, how to tackle, how to tackle. So we call it requirement evolution. Requirement changes are natural things, right? Natural things. In traditional waterfall approach, we freeze requirements. We do one thing and we say, oh, we are done. Now we are into the next stage. So then you can't absorb. But in agile approach, we always, requirement changes are welcome. But of course, we have to negotiate the time, we have to negotiate the cost, but we accept those requirements, okay? But you can't blindly accept everything. We have to manage it. We have to do it in a proper professional manner, okay? Right, so whenever there's a requirement change, there's a process. There's a process. So where the requirement change has to be presented to the team, then they have to agree whether that requirement change is really a needed one, right? Then what is the impact of that change? Do we have to do a lot of changes if some of the modules are already designed and developed? Then we have to agree on the time frame, the cost, as well as when are we going to release that functionality, because we have to change our schedules, right? Our high level plans. And how are we going to test it? So we have to agree on that. So that is how we do it. So that is called requirement management process. Okay, so we do it, but we do it in a very thoughtful manner, right? Controlled manner. Okay, and also whenever there's a change, we have to. It's not only we have to change the product or the code. We have to change our requirement documentations. If there are any use cases or something we have earlier model, we have to change that. We have to update the document, if any. And then only we have to update test cases, right? And of course, we have to do the changes. It's not just do the changes. Then your product and your other artifacts are out of sync. Out of sync. Okay. So those are important. Right. So that's it. So let's go through your VLE note very quickly. Okay. And so we discuss what is requirement engineering or requirement analysis and design. So it's very important that abstract, high level, sometimes you go for detail, right? Formal, informal. Right? It's very, very important that we abstract things, okay? Abstraction is very important. So that is why we need intellectual people. They can abstract out the concepts out of the concrete things. Right, so we discussed the difference between user requirement and system requirements. Okay, so the project stakeholders, right, because they can come up with different versions of the requirements, ambiguities can be there, conflicts can be there. Okay, so they have given you some case studies as well. Then the functional versus non-functional requirements, right? So we discussed that. So non-functional requirements are sometimes called quality attributes, the performance, security, usability. So you can subdivide functional, non-functional requirements into product related and organizational related. right? So the security, maintainability, product related. If you need to follow some standards, these are organizational related, some legal statutory requirements. So these are some typical non-functional requirements we discuss. So then the requirement engineering process: gather, analyze, model, verify. Okay. So requirement elicitation means basically requirement gathering and then the analysis. Okay. So we discussed, right, interviewing or observing or the ethnography, right? Interviews, the closed interview versus open, right, interviews. So what are the attributes that a good interviewer must be having? So then you have to document it. We call it requirement specification. Then the object oriented way, we use the UML diagrams, especially for process. Okay, actors, use cases, relationships. So actor inheritance, extend relationship, the optional functionalities, the include relationships. So these are some include relationships. And so content of a system specification is also there. Okay. And finally the validation, or we have to check whether we have done it properly, right? Reviews, review checks, and how to manage the changes. Right? Requirement evolution. So now you should be in a good position to understand the content. Understand the content, not memorize. හරකෙක් වගේ memorize කරන්න නම් එපා. හරි. අන්තිමට උපාධිධාරී හරකෙක් බී වෙනවා. Right. So that's it for the requirement engineering. Now we are moving to our next topic, the system modeling, architectural design, and implementation. Okay, so we will take those three topics together and discuss because they are highly related. Okay, right. So I'm going to just separate out the recording so that I can upload it as a two. Otherwise, it's going to be very big. Okay, so just I will separate the recording. Okay.